In this section, we're going to look at inequalities and solving them. An inequality is a statement where we are comparing the quantity where it's less than or greater than or less than equal to or greater than or equal to. So the first thing we're going to do is we're going to solve some linear equalities with one variable, and we're going to build our way up to get to different kinds of inequalities that aren't just linear. So this first example we have, we're going to solve the linear inequality, and my best recommendation for you is to just draw a straight line down, and we're going to treat this inequality sign like it were an equal sign. Just going to solve it like we always would. So I'm going to minus the 5 over. I get negative 3x left over is less than negative 12. Divide by negative 3, divide by negative 3. The only trick to inequalities, or as far as rules are concerned in solving, if you divide an inequality by a negative sign or multiply the whole inequality by a -1 or a negative of some sort, you have to flip the sign over. So I just did that. I divided by -3, so my inequality sign flips the other way, and I get 4. So the answers to my inequality are not just one value, it's a range of values where x is less than 4. On a number line, if I were to put 4 and 5's over here and 3's over here, this is an open circle because I cannot equal 4, and I want to be less than it, so I would shade everything down here. To write the solution, we can write this solution in 2 different ways. So the first way is called set builder. And that looks like this. You put a bracket, x such that x is less than 4, and you close the bracket off. There's one version of the answer. That set builder answer is the equivalent in interval notation. In an interval notation, it looks like this. You write from small to big, so I'm always getting smaller than 4, so the smallest thing I can write is negative infinity. Negative infinity always gets a parenthesis because you can't actually touch negative infinity to 4. And because I had an open circle right here, the 4 also gets a parenthesis. If I had had an equal to sign, like a less than or equal to or greater than or equal to, then I would have had closed in color dot, and then I would have used a hard bracket right here at the 4. But I didn't, so. What I just wrote in blue is summarized down here. Where we can write things in interval notation, in set builder notation, and we can use brackets or we can use parentheses. So we're going to use that throughout the rest of the notes as we answer our problems. So let's try another example. So I'm going to draw that red line through my equal sign, and I'm going to move my 3x to the other side. So on the left, I have 4 less than or equal to 7 plus 5x. I'm going to move that 7 over to the other side. So I get -3 less than or equal to 5x. Divide by a 5 and divide by a 5. I do not need to flip the inequality because I did not divide by a negative. You only do it when you divide by a negative. So -3 over 5 is less than or equal to x. So if I were to draw what that looks like on a number line, just so you can see it, here's -3/5. Here's 0. Here's -1. I can actually equal -3/5, so I use a closed-in circle, and I want x to be getting bigger. Remember that alligator wants to eat the bigger thing, so it's chomping at the x, so x is getting bigger. I would shade this way. So with that being said, if I want to write that in interval notation, the smallest thing I am is -3/5, and I can equal it because I have an equal to sign right there. So bracket -3/5, and x is always getting bigger. So infinity, you can never touch infinity. So infinity is always accompanied by the parenthesis. So here is my answer. Okay, let's try another one. It's a word problem. Just because it's a word problem doesn't mean you shouldn't read it. So we're actually going to read. If the revenue and cost of a certain product are given by R equals 4x and C equals 2x plus 100, where x is the number of units produced, and sold, at what production level does R at least equal C? So what I'm looking for is R is bigger than or equal to C. I want it to at least equal C, but I would like my revenue to exceed that. So R stands for revenue, the money you take in, and C is normally your cost, what it costs you to produce it. So in a good system or in a good manufacturing plant, the revenue should exceed the cost because we don't want to be in the red. So let's set this up. So if R is going to be greater than or equal to C, then 4x has to be greater than or equal to C, which is 2x plus 1,000. Can put that red line down the middle. Gonna minus the 2x over. So 2x is greater than or equal to 1,000. Divide by 2. Divide by 2. X is greater than or equal to 500. So if I want to write that in interval notation, that's good habits. I need my smallest number, which is 500, and I can equal that. And as x gets bigger than or approaches infinity with a parenthesis, then my revenue will continue to exceed my cost. Okay, this next one's a little bit different because it's called a three-part inequality, and it has, in theory, sandwiched the x value between two things. So instead of writing one red line, I'm actually going to have two. And in an equation, if you do it to one side, you have to do it to the other side. So for this problem, if I do it to any part, I have to do it to all parts. So first of all, let's minus this 5. So if I minus a 5 here, it has to happen in both the outside pieces. That results in a -7 is less than 3x is less than 15. Divide by 3. If you divide by 3, then both outside pieces need to divide by 3 as well. -7 over 3 is less than x is less than 5. So that means my smallest number I can be is 7 over 3. And it's a parenthesis because I cannot equal it. I do not have those equal lines under my inequality. The biggest number I can be is 5. And again, I cannot equal 5. I only can get really close to it. And that's your answer. So the next problem is going to be a quadratic. And so just because we have a quadratic, we're going to use our factoring skills that we did in the review chapter and that we did in 3.1 through 3.5. We're going to factor and then deal with the fact that it's in an inequality. So first, let's just do what we know how to do. So the steps say solve for the corresponding equation, which is what I just said. We're going to pretend it's a regular quadratic. Then we're going to use those zeros, the solutions that we find, and we're going to make a number line. So let's take this piece by piece. So let's see if we can factor this. X and x. I need two factors of -12 that add and make a -1. So -4 and +3. -4 times 3 make a -12. -4 plus 3 make a -1. And I'm going to let these equal 0. Once you factor, you set each piece equal to 0. So x minus 4 equals 0, x plus 3 equals 0, x equals 4, x equals negative 3. So that's the normal basic thing we do. These things are my zeros. They're my key points that I need to put on my number line. So I'm going to make a number line now. And I'm going to put my key values on there in the proper order. So here's negative 3, and here's 4. This equation came from an inequality, and the inequality just said quadratic is less than. So on my number line, I'm going to put open circles because I can never equal. I only can get close to. Then I'm going to pick a number that is outside my my key value. So for example, something that is smaller than negative 3 over here I could test is negative 4. In between negative 3 and 4, I can use 0. And honestly, you can use any number that is in that interval. I'm just picking what I think is the easiest. 0 is pretty easy to plug in. And then something bigger than 4 is 5. So then this is what we do. I'm going to plug in, and I like to use my factored version. I'm going to do negative 4 minus 4, negative 4 plus 3. So this is going to make a negative 8 times a negative 1. A negative times a negative is a positive. And what I'm looking at is this right here. Is a positive, and since it's positive, I'm going to shade above the line. If it were a negative, I would shade below the line. What your book does, let me just draw a line. Your book looks at it in a very different way, which is equivalent. Your book says, okay, a negative 8 times a negative 1 is a positive 8. Positive 8, and if you compare it to what you had, less than 0. Positive 8 less than 0 is false. So you shade above. I prefer my way because if it's a positive, you shade up, and if it's a negative, you shade down. You can pick whichever way works for you. So now I have my 0. So 0 minus 4, 0 plus 3. This is going to be a negative 4 times a positive 3. A negative times a positive is a negative, so I'm going to shade below. Your book would have said that negative 12 is less than 0, and so you would shade below because it was true. And then 5 over here, I get 5 minus 4 times 5 plus 3. So this is a 1 times an 8, which is a positive, and we're going to shade up. Your book would say, so the 8 less than 0 is a false, so you shade up. And so the question is, where is my parabola less than 0? And the answer to that is this piece right here. So my answer is parenthesis, because I cannot equal it. So parenthesis, negative 3, comma 4 with another parenthesis. Okay, so let's try a little bit of a more challenging quadratic. So this quadratic has a leading coefficient, so a little bit more steps, a few more steps to factor. So you can box. I'm going to do the AC method. 2 times negative 12 is negative 24. 2 factors of negative 24 that make 5. If you're not sure, do your little factoring tree. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then some hints here. It's a negative, so only one of them is negative, and they have to add up to be a positive, which means you want the smaller one to be negative, because a smaller negative plus a bigger positive will make a positive when you add them. And my winning pair are negative 3 and 8. So I'm going to rewrite this as 2x squared plus 8x minus 3x minus 12 greater than or equal to 0. I haven't changed anything, because if you go in here and combine these two like terms, you go back to your 5x. And now what's a factor by grouping? The first two are, I'm going to call them red group. Second two I'm going to call the green group. So my red group, they have a 2x in common, leaving you with an x plus 4. In my green group, they have a minus 3 in common, leaving you with an x plus 4. Both groups, red and green, have an x plus 4 that you pull out, and then you're left with a 2x minus 3 greater than or equal to 0. So my zeros, my key numbers, come from these two factors, x plus 4, we're going to say equals 0, and 2x minus 3 equals 0. So x equals negative 4, and x equals 3 halves. So I'm going to put this on a number line. So negative 4 is way down here. 3 halves is right here. And then I'm going to pick numbers. I'm going to pick negative 5, 0, and 3 halves is 1.5. So I'm going to pick a 3 down here. So when I go back and compare, because there's a 0 right here, I can use this. So the method that I'm using versus what your book is using, as long as you have the 0 on one side, you can just shade positive up and negative down. But if you have something on the other side, then you have to do the true and false version, which is what your book does. So if I plug in a negative 5, and again, I like to plug into my factored version right here. It just makes it easier for me. Negative 5 plus 4, 2 times negative 5 minus 3. This is going to be a negative 1. 2 times negative 5 is negative 10, minus 3 more is going to make a negative 13. A negative times a negative is a positive, so I'm going to shade up. I can equal 4 because it says equal to right there. So my 4 gets a closed dot, and my 3 halves gets a closed dot. When I plug in 0, I get 0 plus 4. 2 times 0 minus 3. This is going to be a 4 and a minus 3, which is going to result in a negative, so I'm going to shade below. And then the 3, I'm going to get 3 plus 4. 2 times 3 minus 3. It's going to be 7. 6 minus 3 is 3. Positive, so we're going to shade up. And then we pick the piece that answers our question. We wanted our parabola quadratic thing to be greater than 0. So I need to pick the pieces that I shaded up, which are greater than 0. So that's going to be negative infinity, comma, negative 4 with a bracket, because this time I can equal and touch negative 4. You put your U for union, and then you go skip over to 3 halves with a bracket, because you can touch it, to infinity. So not super bad, just some algebra steps. Okay, staying with quadratics, let's do an application problem. So they give us the formula for finding the height of a projectile. If a projectile is launched from the ground with an initial velocity of 96 feet per second, its height s in feet t seconds after launching is given by the following equation. When will the projectile be greater than 80 feet above the ground? So this 80 is my s, my distance above the ground. So I'm going to plug that in, 80, and it wants my projectile to be greater than 80. So 80 is the smaller end. So 80 is less than negative 16t squared plus 96t. This is a quadratic, and we want it to equal 0. So I want to minus the 80 over. 0 is less than negative 16t squared plus 96t minus 80. Please note when you subtract something over, you don't flip the inequality sign. But then the next step, I'm going to divide everything. Sorry, I grabbed the wrong tool. I'm going to divide everything by a negative 16. Because I'm dividing by a negative, I'm going to have to flip that inequality sign. So 0 is now greater than t squared. 16 goes into 96. 6 times a positive divided by a negative is a negative 6t. A negative divided by a negative is a positive. And 80 divided by 16 is 5. By dividing everything by a negative 16, this is a much nicer quadratic to deal with. So 0 is greater than t and t. 2 factors of 5, well, the only factors of 5 are 1 and 5. They need to multiply to be a positive, but add to be a negative. So a negative times a negative makes a positive, and a negative plus a negative is a more negative. So minus 1 minus 5. So you take these factors and you let them equal 0, so you can find your key numbers or your zeros. So t equals 1 and t equals 5. I'm going to put this on a number line in order, 1, 5. I'm going to use this version right here. The zeros on one side, it's nice and factored. I'm going to plug in zeros down here. There's a 3 in here and a 6 here. So when I plug in 0, I get 0 minus 1, 0 minus 5. That's going to be a negative 1 times a negative 5, which is going to result in a positive. So I'm going to shade above. This problem says only less than. So my critical numbers, my key numbers, get the open circles. When I plug in my 3, I get 3 minus 1, 3 minus 5. This is going to be a negative 2. No, sorry, a positive 2 times a negative 2, which is going to make a negative. So I'm going to shade below. When I plug in 6, I get 6 minus 1, 6 minus 5, which is a positive, times a positive, which is a positive. So I'm going to shade up. And the question here is, where is my thing less than 0? So less than 0 means you shaded below. So my answer is going to be 1, 5 with parentheses because I don't actually touch those values. Our last type of inequalities we're going to deal with is called a rational inequality. It's because we have a fraction with the x in the bottom, so we're going to deal with these. We're going to follow the steps. It says rewrite the inequality if necessary so that you have 0 on one side, and there's only a single fraction. So let's start with that step for the first problem. So first of all, I only have one fraction right now, but I don't equal 0. So I'm going to minus the 1 over. So I'm going to get 5 over x plus 4 minus 1 is now greater than or equal to 0. I need to combine so that I only have one fraction. So this 1 right here, I'm going to write as this denominator, x plus 4 over x plus 4. Because something divided by the same something is always 1. So I can rewrite what I have. I have 5 over x plus 4 minus x plus 4 over x plus 4. And I'm going to make one very strong warning. This negative has to go to both of these. You are subtracting the entire quantity. So 5 over x plus 4 plus, I'm just going to distribute that negative up front so I don't drop it off. So now, because these denominators are the same, we can combine the numerators. So I get 5 minus x minus 4 over x plus 4. And this is, again, greater than or equal to 0. And when I combine these, 5 minus 4 is a 1. So I get 1 minus x over x plus 4 greater than or equal to 0. Okay, so now my critical numbers, my key numbers, my important numbers come from the top and from the bottom. So 1 minus x, I'm going to let that equal 0. And x plus 4 is going to equal 0. So in this case, 1 equals x and x equals -4. Those are numbers I'm going to put on my number line. Sorry, click the page. Okay, so let's put those numbers on my number line. So I'm going to get down here -4, and right here I'm going to put the 1. And now this is the key thing you need to know. The numbers that come from the numerator can have a closed circle, and they will because it says equals to, so the 1 gets a closed circle. But the critical number, the key numbers that come from the denominator, never get a closed circle. They always get an open circle, because if I go right here and I plug in -4, -4 plus 4 is a 0, and you cannot have a 0 in the denominator. So the things that come from the denominator always are open circles. Then you pick your numbers to plug in. So I'm going to do -5, 0, and 2. And I'm going to use this yellow box thing right here to do exactly what we did before. So when I plug my -5 in, I get I get 1 minus -5 over -5 plus 4. Minus makes a plus. So on top, I'm going to get a 6 over a -1, which is going to be a negative. So because it's negative, I'm going to shade below. For 0, I get 1 minus 0 over 0 plus 4, which is 1 over 4, which is a positive, so I'm going to shade above. And then for 2, I get 1 minus 2 over 2 plus 4, which is going to be a -1 over a 6, so I'm going to shade below. This inequality says, where is my fraction thing greater than 0? My answer is parenthesis -4 to 1, and the 1 gets a bracket. So this is my answer. Okay, one more time, last problem. Okay, so I follow the same rules. It needs to equal 0 first, so let's make that happen. 2x minus 1, 3x plus 4, minus 5, less than 0. That 5 by itself is a problem, so I'm going to multiply by 3x plus 4 over 3x plus 4, because that's like multiplying by 1, and that is this one's denominator, which is why I picked that. So now I get 2x minus 1 over 3x plus 4. Remember my warning. You should just add the opposite up front. Distribute that negative in so that we don't mess up and drop the negative. Plus, distribute into the numerator, because this is like 5 over 1. So the 1 would go to the denominator. So you get -15x minus 20 over 3x plus 4 is less than 0. Because these denominators are the same, you're going to add the numerator straight across. So 2x minus 15x is -13x. -1 minus 20 is -21. All over 3x plus 4 less than 0. So then we take each piece, the numerator and the denominator, and we set them each equal to 0. -13x minus 21 equals 0. -13x equals 21. X equals 21 over -13. So there's a critical number. Right here for this one, 3x plus 4 is going to equal 0. 3x equals -4, so x equals -4/3. So those are my two critical numbers, and those are the two things that are going to go on my number line. On my number line, -21 over 13 is smaller than, it's -1.6 and some change. -4/3, because that is negative 1.3 repeating. The numbers I can pick, this isn't quite negative 2 because 13 times 2 is 26. So I can do negative 2. And here I can do negative 1.5. And over here, let's pick 0. I'm plugging these into this right here and comparing. So if I do negative 2, I get negative 13 times negative 2 minus 21 over 3 times negative 2 plus 4. Negative 13 times negative 2 is going to be 26. 26 minus 21 is a 5. On bottom, I'm going to get negative 6 plus 4, which is going to be a negative 2. This is a negative, so I'm going to shade below. This does not equal ever, so both of my black numbers that I have on my number line, my critical numbers, get open circles. When I plug in negative 1.5, I get negative 13 times negative 1.5 minus 21 over 3 times negative 1.5 plus 4. On top, I'm going to get positive 19.5 minus 21. It's negative 1.5. On bottom, I'm going to get negative 4.5. Nope, yeah, negative 4.5, and then from that I'm going to add 4 and get negative 0.5. So a negative divided by negative is a positive, so I'm going to shade below. No, sorry, I take that back. A negative divided by negative is a positive, so I'm going to shade above. And then when I plug in 0, I get negative 13 times 0 minus 21 over 3 times 0 plus 4. 0 times anything is 0 minus 21 is going to be a negative 21 over a positive 4, which is going to be a negative. The question here was, when is this thing less than 0, aka when is it negative? So the answer to that question is when I shaded below. So from negative infinity to negative 21 over 13, union negative 4 over 3, comma, infinity. It's just this piece in between where I'm greater than 0. So there is my answer.